Alright, here we go. Question number 16 from our Precalculus homework number 11 in MyLab Math. We have a Geogebra question. They want us to write an equation of an ellipse given its foci. So let's click the link to open the Geogebra window. And here it says write an equation for a curve. This would indicate an ellipse in this case, so that the sum of the distances from the 2 points to any point on the curve is 6.8. So the 2 points they give us are -1, 5 and +1, 5. So writing this information down in our scratch work, we've got our foci written. Now we do know the center is right in the middle of the foci. So, given the foci, we can determine that the center is going to be halfway between the x-coordinates, which would be 0, and at the same height as the foci. So what does that tell us? Well, the center of an ellipse is the ordered pair h, k, so that gives us the value of h and k. Noticing that the y-coordinates are identical for the foci would lead us to conclude that we want to use this formula for the foci because the y-coordinate is simply k, which means that the y-coordinate would have to be the same for both foci. And then we can see that the x-coordinates would have to be h plus or minus c. So h plus c would have to be the larger of the two x-coordinates, which in this case would be the 1. H minus c would have to be the smaller of the two x-coordinates, -1. And in this case, we can solve for c if we distribute a negative to the bottom equation. So here adding, the h's will cancel. C plus c gives me 2c. 1 plus 1 is 2. Dividing both sides by 2 gives me a c value of 1. Now, in order to find this equation, we are going to need h and k, and we are going to need a and b. So I have yet to find the values for a or b, but if we scroll up and zoom in, I want you to notice that 2a equals the sum of the distances from a point to the foci. So 2a would indicate our constant sum, and this sum is always a constant, the sum of the distances from a point to the foci. So going back to our Geogebra question, it says the sum of the distances from the 2 points to any point on the curve is 6.8. And so now we can set up another equation knowing that 2a must equal the sum of the distances from the foci to the point on the curve. And dividing both sides by 2, we can determine the value of a is going to be 3.4. And we have one more piece to find, and that is b. And we do have a formula for an ellipse right here. A squared equals b squared plus c squared. So using this relationship, doing a little plug and play, we're going to have 3.4 squared equals 1 squared plus b squared, and subtracting 1 squared from both sides will give us b squared. And this is a great time to bring in the Casio Class Whiz. 3.4 squared minus 1 squared, which is just 1, is going to give us a decimal value of 10.56. So we can see that b squared is 10.56. And now we have all of the information needed to write the equation of our ellipse. So going back to our information sheet, knowing that we used this formula for the foci will indicate that we're going to use this formula to find the equation of our ellipse. All right, so starting with our formula and doing a little plug and play, we're going to have x minus h. Recall that h was 0, so that'll be x minus 0 squared divided by a squared. Recall that a was 3.4, so that would be 3.4 squared plus y minus k squared recall that k was 5 and then divided by b squared, which we already have b squared, 10.56, and then the last thing I need to do is simplify. So, using our class whiz, we've got 3.4 squared is 11.56 as a decimal, and x minus 0 is just going to be x squared. And then on the other side, nothing is going to simplify. So that's still going to be y minus 5 squared over 10.5 equal to 1. That standard form of an ellipse must always equal to 1. And now we need to take this answer back to our GeoGebra window and see if we're right. So here I have entered my equation, the left-hand side, and remember the right-hand side is always 1, and checking to see if we're right. And that is correct. And that's going to do it for this problem. So one more time, please don't forget to click Save and Submit to update your progress in your MyLab Math. And if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.